All right, guys, welcome back. We're going to do the third part of our lesson one for BC Calculus, and this lesson is talking about limits that are compositions. And I want to just say that we're going to do that with these crazy, lovely graphs that were created for us. And we're going to look at two functions that we're taking limits of. We're going to do examples where we're adding functions together, the limits of functions added together. We're going to look at examples where we're multiplying them, and then we're looking at examples where we're doing compositions. So these are the 9 examples that I'm going to do in this video. I want to say that some of this is straightforward, but some of this is not. So we want to really make sure that we look at what's happening in our graphs when we do these exact problems. And let's start out with an easy one, right? Let's go with something that's not so crazy hard. So if you look at example number 1, we're taking the limit as x approaches 0 from the left of the function f of x plus the function g of x. So the first thing that I'm going to do is I'm going to go ahead and look at the limit as x approaches 0 for both these things. So this is where we're going, right? So we're looking at 0. And so we're going to write down them separately because we want to see what they are separately. And then we just simply have to add them together. So that's one of our properties. Is if I can find the limit as x approaches 0 from the left of f of x and find that value. And let's look at that right now. So if I'm looking at f of x, the value to the left is going to be, we're approaching this from this right here, this line right here, we're approaching it, we're going to get 1. And then we're going to look at the limit as x approaches 0 from the left of g of x, right? So we're just doing that. And so we're over here now, and we're looking at 0 from the left here, which is 2. Remember, in limits, we do not care if it's open or closed, all right? We're not talking about continuity. It's just the fact that this is going towards 2. Right, at x equals 0. So we have the fact that this is 1, we have the fact that this is 2, so the limit as x approaches 0 from the left of f of x plus g of x is simply going to be the summation of those two numbers, and so this answer is going to be equal to 3. So very easy, really awesome problem for us to do, all right? So if that made sense to you, then example number 2 will also make sense to you, because now we're just going to look at both of the functions from the right. So we're going to go back up here, and now we're going to start looking at the function from the right. Well, again, we're hitting 1 for this function, and the limit as x approaches 0 from the left of g of of the right of g of x, and so from the right of g of x is also 2, and so this is also going to be 3, right? We're just going to add up 1 plus 2. And so we've done all the work that we need to do. All of this is done. Remember that if we're trying to find the overall limit, and we already know what the left-hand limit is and what the right-hand limit is, if they're equal to each other, then they are equal to the overall limit. So if the left-hand limit is equal to the right-hand limit, then that limit exists, and that overall limit is equal to that value. So all this work is done for number 3. All right? So pretty straightforward with that. So hopefully that makes sense, and I'm going to erase this and I'll come right back to you. Okay, so now we're going to look at products. We're going to look at 2 product problems. We're still looking at x equals 0 here. And so notice that this one, it's the overall, right? It's the overall limit. So just like in examples 1, 2, and 3, or really just 1 and 2, you're just going to look at the limit as x approaches 0 of f of x, which we can see right here is going to be 1. And then we can look at the limit as x approaches 0 of g of x, and again we're over here, and that's 2, and we already knew that because we knew that the left hand limit for x equals 0 of f of x was 1, and the right hand limit of f of x was also 1. So we knew this was already 1 without even looking at the graphs. So this overall limit right here is going to be 1 times 2, which is going to be equal to 2. Okay, so those are the very straightforward questions. All right, those are the ones that does not require too much thought. So let's get into something a little bit more interesting. What's happening in this one? So if you look at x equals, the limit is x equals 1. So now we're going to go over here to 1, and we're like, oh my lord, there's a jump, this continuity here, right? So for both the 1s and over here too, there's both of that. So we're still going to do the same thing we did before. Now this is going to require a good amount of work because we're looking at the overall limit. I wish I had more room for this. So I may write it over here and then I'll erase it a little bit later. So I'm going to try to go through this one a little bit slower because I want to make sure that you guys do understand it. We're going to take basically everything that we did here and we're going to compile it down here. So we want to take the limit. Remember, if the overall limit exists, then the left and right hand limits have to also exist. So we're going to look at what's the left hand limit of f of x, which we at x equals 1, right? So we're going to go up here to 1 for f of x, and we're going to look at what's happening on the left side. The left side, right here, so on the left side of this line, we hit at -2. So the left-hand limit for this function is at -2. We're going to do the same thing with g of x. Okay, so we're looking at just the left-hand limits of those two things, because we're looking at the overall left-hand limit. So g of x. So if we go over here, the left-hand limit is actually 1, right? Because we're going over here, it's going to be at 1. And so I know that the overall limit, I'm going to write over here too, because this is so I know that the overall left-hand limit of f of x times g of x, I would multiply these two numbers together, right? So this right here is just going to be the product of those two numbers. So this is going to be equal to -2. So the left-hand limit is equal to -2. So hopefully that makes sense. If it doesn't quite click yet, then don't worry. I'm going to do it exactly again now with the right-hand limit. So now I want to do the same thing. I want to look at the limit as x approaches 1 from the right of f of x. And so again, I'm going to look over here at this one, and to the right, it's at 1, right? We're looking up here at 1. So if I'm going to this line, I'm hitting at y equals 1. So this is 1. Notice that these are not equal to each other and does not have to be, because we're looking at this right here, the product of these two functions. So the overall limit of f of x does not exist because we actually know that already because it's a jump discontinuity. But we're not looking at f of x, we're looking at the product of f of x, g of x. So we're going to look at the limit as x approaches 1 from the left, sorry, from the right of, I'm so used to doing that, right? Left, right, left, right. So that's a little bit of a mess right there. So let me clean this little guy up for us. All right, let's do that. Okay, so the limit as x approaches 1 from the right of g of x. And so from g of x, right here, we're going to look at that, and it's going to hit at -2. So this overall limit, the right of f of x times g of x is going to be equal to the product of 1 times -2, which is also equal to -2. So your left-hand limit is -2, your right-hand limit is -2. Therefore, we've done all the work like we did in 1 and 2, and we get that this is also equal to -2. So that one does require a good amount of work. This is a BC question. This is one of the questions that you would see on an assessment. I don't see it being on the actual exam in this fashion, but they may have examples where it's pretty easy for you to do, like you can see up here. You didn't have to write all the notation out. Most likely, this is probably multiple choice, and so you could just do it in your head, like, oh, let me see what my left-hand limit is. Oh, that's -2. What's my left-hand limit here? 1. So that's going to be -2 times 1, which is -2. Over here, it's 1 times -2. Oh, wait, they're both -2, so the answer is -2. Right? And I know I said that very, very, very quickly, and so I will do a little bit better with that in class, but I just want you guys to be able to understand that, okay? So this answer is -2. I'm going to erase some of this. I just want to make sure that you guys are okay with it, because we're going to do a couple more of these, all right? Then we're going to do a little bit more of piecewise functions. So if you need to take a break and just calm down and pause it first and calm down, take a break and do so, and I'm going to erase. I'll be right back. Okay, so we're going to try one more of these, and we're looking now at the limit as x approaches 3. And again, it doesn't really matter if we're adding the functions together or multiplying the functions together or subtracting the functions together. If we're subtracting, by the way, like for this right here, number 1, if this had been minus g of x, and I should have said this earlier, this should have been 1 minus 2, the answer would have been -1. All right, so that's what that would have done. So if you look at 3, and again, ladies and gentlemen, I would suggest maybe you can kind of do it ahead of me, like pause the video and see what's going on with this. So you can see that x equals 3. We also have a piecewise function. And so we're going to break it up again like we did with example number 5. So we're going to look at the limit as x approaches 3 from the left of f of x. And I'm going to try to write a little bit smaller for this one. And then we're going to write as x approaches 3 from the left of g of x. So this is kind of how I think about it. And we're going to add these two numbers up. And that's going to be the left-hand limit, right? And then I'm going to go ahead and write down what we need to do. Because sometimes students just like to see, like, okay, what I need to do first before I find the values. And then we're going to find the right-hand limit for this. Notice all my notation, right? All my notation, the right-hand limit for g of x. And remember, we're looking at the sum of these two numbers and the sum of these two numbers. We don't care if these are equal and these are equal, because we're not looking at the actual function. We're looking at what's going on with our functions that we're adding up. So let's go ahead and plug these values in. And so 3 from the left. So we're looking at f of x right now, 3 from the left. So if I'm on this line right here, 3 from the left, I'm coming this way, and I'm hitting at 1, right? So this value here is 1. Let's go ahead and just do 3 from the right, right? So 3 from the right, I'm going this way, I'm going down here to this, I hit the function, and it's at -2. All right, so I clearly know that this limit does not exist at x equals 3, because again, the left and right-hand limit doesn't exist, but we don't really care about that. Over here, we're going to look at now x equals 3. Well, from the left, we're going to come up here, and we're going to get 3, right? It's hitting it at 3, because we're going over here to this value here. And then we're going over to the right-hand side. This is at 1. And so what we're going to do now is we're going to look at the left hand, and I'm going to write this up here for us. So the limit as x approaches 3 from the left of f of x plus g of x, that's going to equal the summation of these two numbers, which is 4. And then the limit as x approaches 3 from the right of f of x plus g of x, and that's going to be the summation of these two numbers right here, which is -1. So you already know before I tell you this, but you automatically know that this limit right here is not going to exist, right? And we wanted to show you an example where it's not going to exist. So don't feel like, oh my God, I must have done something wrong because these numbers did not match up. These sums didn't match up. It's not going to always work like that. So in this particular example, it does not exist. All right. So hopefully that makes sense to you guys. Hopefully we got some more energy. We got 3 more to do, compositions. But if that doesn't make sense, then you guys can obviously come talk to me in class. Okay. So let's move on to our last 3 examples. All right. So I want to go ahead and I edited this a little bit so these questions will be up here for us, so I don't have to keep scrolling back and down for what we're going to do next. Okay. So now we're going to do compositions, and again, it does get a little complicated, but just hear me out for these particular questions. So the first thing about compositions that you should be able to know, or the first thing I'm going to show you, is that you're going to be able to take the outside function. So this is, limit as x approaches 2 of g of f of x. So you're going to take the outside function, and right now we're going to leave that outside, and we're going to write the function, the limit as x approaches 2 of just f of x. Okay. Now, I wanted to be very clear about something really fast. This value that we're going to find right here, it's not going to be g of that number. So if this value happens to be 1, then we're not going to go over here to g of 1 and find out where it is. This is a limit, okay? And then we have to worry about that both of these are limits. So I just want to clarify by saying really fast, we're going to find this value, you're going to see what I'm going to do with it. So the limit as x approaches 2 of f of x. Well, this, thank the Lord, is not a piecewise function, right? It's so nice for us. We don't have to worry about doing the left-hand side and the right-hand side. It literally is 2, okay? It's literally 2. So we're going to go to the limit. Actually, let me do this. So this is going to be equal to 2. This limit here is going to be equal to 2. And so we're going to delimit as x approaches now this new value. I hate I don't hate, but like if this had been a 3, then this number would be a 3, all right? So whatever, that's why I'm changing colors. So whatever this number is for this function right here, that's going to be your new value that's going to be right here now of g of x. Okay, so I just want to very quickly understand that we're now still doing the limit of f, and now we got to find the limit of g, right? Because you work your way inside out. So the limit is x approaches 2 of g of x. So again, this number right here is going to be whatever the value of this is here. So if we go over here to g and we look at 2, we're like, oh, there's a piecewise function here. And then you're thinking to yourself, okay, well, then this answer does not exist. Well, this is where, again, you have to do a little bit more thinking. This answer will exist, all right, because of how this is presented over here. Now, this is where students get a little bit confused, so if I hopefully can explain this to you guys pretty well. So if I'm looking at x equals 2, all right, I'm going back to this limit for a second. So if I'm looking at the limit as x approaches 2 of f of x, from the left, it's 2, and from the right, it's also 2. But what I want you guys to understand is that if I'm approaching 2 from the left or from the right, both of these, I'm approaching it from the bottom of 2. From the bottom of 2. Or, let's say it, from the left of 2. Right? If you look back at the number line, if we were to turn this upside down and we look at 2, I'm approaching 2 from the left here. And on the right side, I'm also approaching 2 from the left. So I'm looking for the left-hand side. So this graph, which I need to get rid of for you guys, this graph, if you can see this now that I've got all my craziness going on here. So since I'm approaching from both the bottom, for both left and right, then I want to edit this, and now I want to make it 2 from the left. If this had been down like this, and one was going to the left and one to the right, or bottom and top, then this limit would not exist. If I had flip-flopped it, and I had looked at it like this, right, if it had been up here, then I would be looking at it from the right. So this tells you the direction based on what I'm looking for right here. I tell my students, simply, guys, if you draw a line right here, if it's below the line, if both of them are below the line, it's going to be the left-hand limit. And if it's above the line, both of them are below the line, it's going to be the right-hand limit. I mean, that's really the easiest way for me to explain it to you. And so if we're looking over here at -2, from G, it's going to be this value right here, which is going to be -1. Okay, -1. So hopefully that makes sense. If not, sometimes students just learn the process of what's going on. So you can apply both of these to what we just did right here. So I encourage you to pause it if you need to and see if you can do example number 8 and 9, and then we're going to come back in a second and we're going to check our answers. Okay, so we're going to go ahead and we're going to do example number 8, number 9, and then this will be the end of our first lesson of BC Calculus. So we're going to look at the limit as x approaches 0 of g of x, and I'm going to just go ahead and bring my first function out here. And so obviously whatever this first function is what comes out of this. And so if we're looking at the limit as x approaches 0 of g of x, so we're now looking over here at this value. And so I like this example because it actually ends up being equal to 2, right? This limit right here is actually equal to 2. So the limit as x approaches 0 from the left and to the right is actually at 2. Again, we do not care that there's an open circle right there. So we are now going to write the limit as x approaches 2, right? Because this whole value right here, is equal to 2. So whatever this number is, this limit, now we're going to look at the function of f of x at that value. And so if we go back over here to 2, this is an awesome example because there's no piecewise function here. We know that the limit to the left and the right are equal to each other. So I didn't have to go over here and worry about what's bottom or top or whatever. I know that this limit, like just go back to basic graphs now of limits. If I ask you guys just given this function of f of x, this graph, and I said, what's the limit of x approaches 2? Every one of you would tell me the answer is 2, and that's correct. So again, I'm showing you guys an example where it doesn't have to get crazy, right? And so this is the kind of examples that you would probably see if they did put one on the BC exam. This is probably the one that you would do, right? Something pretty straightforward where you don't have to think a little bit. All right, guys, we have one more question left in this lesson, and it's question number 9. And I just want to preface by saying that this question is a pretty crazy problem, but if you understand what I do in number 9, then you've understood everything that I've talked about in this video. So let's take a look at it and see what we can do with it. And I'm going to need a lot of room, so I'm going to start over here for it. So the limit as x approaches 3 of f of g of x. So just like we've done in the previous examples, 7 and 8 here, we're going to go ahead and put the f on the outside, and we're going to do the limit as x approaches 3 of g of x. Okay? Now we look at this, and we get back to, you got to be kidding me, right? You got to be kidding me. Look at this. It's another piecewise function. So just like before, we have to do a left and we have to do a right. Right? We just cannot assume, because again, it's not looking at g of x. We're looking at the composition of this. So we have to look at the left-hand side and the right-hand side and see if these overall things, these processes at the end is going to be equal to the same number like we did over here. So if we look at 3 from the left, so 3 from the left, we're going to get the value of 3. So know that this equals 3, right? This value right here equals 3. So then I'm going to write the limit as x approaches 3 of f of x. Okay, so again, whatever this number is right here, we place it right there. We come over here to 3, and we're like, again, oh my goodness, you have to be kidding me, right? So again, we have a piecewise function. I'm never going to test you on something like this. I'm just telling you that right now. But again, I just want to challenge you guys a little bit on this higher level thinking. So got a piecewise function. So just like we talked about in example number 7, if you're looking at 3, right, 3 from the left, we kind of draw ourselves a horizontal line, and notice that again, it's coming from us from above, or the right hand side, right? The right hand side of 3, because we're starting at 4, right? 4 to 3, we're going the right hand side, so we have to go to the right hand side of this. And so if we go right hand side of this function, we're going to get the answer is -2. So the first half of this is -2. And then we're going to go and look at the next example, and we're going to look at the limit. Oh, I got to figure out what this is first, right? All right, so the limit as x approaches 3 from the right. So g from the right. G from the right is 1, right? This is 1. So I know that this value right here is 1. So now x approaches 1 of g of x, sorry, of f of x. So I come over here to 1, and just like before, like I said, I'm never going to test you guys on this, so please don't forget about it. But again, we have a piecewise function. But looking at this one, this example right here, we're looking at, draw our little horizontal line, we're coming in it from the bottom, right? We're coming in from the bottom. So this is going to be 1 from the left. And if we look at 1 from the left, this is why my color coding is a little crazy here. So 1 from the left, we're looking at this guy right here. From the left, right, left hand side, we also hit -2. -2. So this whole crazy process, this whole crazy thing actually just says that this overall limit is -2. This is probably the most complicated thing, and I know there's some of you guys that followed along with me very, very well. If you're like, oh my God, what the heck did he just do? Then don't worry, I'm not going to assess you on something crazy like this. I would expect you guys to be able to do number 7. I think that that would be a fair one. So this would be my expectation. This is the one straightforward one where this would be a solid number. You just have to do the left hand side or the right hand side. And this would be more so like the BC exam. All right. So I'm going to leave you there. I know we're probably, oh my God, too much thinking for this. But hopefully this made somewhat of sense to you guys. And we're ready for our lesson number 2. I will just say very quickly that for you guys, I'm not going to have a video of this blueberry pancake recipe thing. These are all just practice problems, the answer keys on Schoology for you guys to look at and whatnot, but it's just pretty basic stuff for you, so I don't need to do a video for it. So anyways, that's the end of lesson number 1, and let's move on to more limits with lesson number 2. So hopefully you guys watch these 3 videos, and if you have any questions, obviously hit me up on email or let's talk to me in class. All right.